we're just gonna start now. So, okay. So hopefully you know how to do number 1. If not, it's okay. I'm actually not gonna give you the answers first. I'm gonna, since we're going over all of these today, as soon as I cover the first topic, I'll give you the answer to this one, second, that, and then so on. Ignore that first. So I'm gonna go over what is graphing. So this is a Google definition of graphing. It is a diagram showing the relationship of quantities, and it's especially a diagram in which lines, bars, or proportional areas represent how one quantity depends on or changes with another. That's kind of complex, but basically in math, graphing is just using the Cartesian plane, or the x-y graph, which looks like, which looks like a cross, like that, and then and drawing lines, points, and stuff like that to find the solution to your equation. Remember last week we taught you guys substitution and elimination to solve equations. Now graphing is actually another way of solving these equations. It's more complex and takes more time than substitution and elimination, but in most cases it works. Okay, let's keep going. Shoot. In pre-algebra, you guys probably learned about this equation right here. I'll write it again. Y equals mx plus b. Now, can someone tell me what m means? You can just unmute yourself. All right, that's okay. So m is the slope. Now, what is the slope? The slope is just the change in y over the change in x. So in other words, we can say it as rise over run. This sign right here, a triangle, which will be used on in later advanced math, is called delta. And delta just means a change in, like right here. So slope is also called delta y over delta x. So change in y over change in x. And that's the slope. That's m right here. Now, does anyone know what b is?
The intercept.
Right. It's the intercept. It's the y-intercept. So then, yeah, this is where the graph will intersect with the y-axis. So for example, this point. So it's going to be 0, b. It's always going to be somewhere on this line. So for example, if the graph goes here, let's say this point is 0, -2, then b would be -2. That's the y-axis. Oh, yeah, Lydia, yeah, yes, good job. It's the y-axis, y-intercept. All right, let's keep going. So then how do you graph a simple equation like this, a y equals mx plus b graph? So the first thing to do is find points to graph. And for example, the y-intercept. So then what I like to do is to find values for x and then plug it into the equation to derive the y value. For example, we're going to find the y-intercept first. Now the y-intercept is when x equals 0. Y equals 6 times 0 plus 9. So then 6 times 0 is 0. So then y equals 9. So we know that if we plug x into the equation, x equals 0 into the equation, we get y equals 9. So I'm going to hand draw the graphs first, but I'll show you guys on Desmos, which is a graphing calculator device online. So then we know that 0, 9 is a point. So this is the x-axis, this is the y-axis. Now x is 0, so it's right here. Let's just say 9 is right here. So y equals 9. So this right here is the y-intercept. That's one of our points. Now to graph an equation like this, a y equal mx plus b equation, we need at least 2 points. We can't graph it with 1, we need 2. So what do? We can assign another value to x and plug into the equation and derive another value for y. So what I'm going to do is to use 1. So y equals 6 times 1 plus 9. Now we solve it. 6 times 1 is 6. 6 plus 9 is 15. So the numbers are kind of big. That's because of a problem. So we know that another point is 1 comma 15 because when we plug 1 in, we get 15. So let's just assume this is 1 right here. And then 15 is somewhere all the way up here. Now, after you plot these 2 points on a graph, what we're going to do is connect them like this. On the paper, you would use a ruler and carefully graph it, but I can't really do that on here. But the line would look like this. It goes infinitely because in y equals mx plus b, in this question, there's no restrictions. So it's going to go all the way here, all the way there. But you don't have to draw it. I'll show you guys on Desmos real quick. Let me clear my drawings real quick. So I'll show you guys on Desmos real quick. Wait, tell me if you guys can see. Shoot. Okay. Tell me if you guys can see it. Can you guys see it? No. Okay. So what was our equation? Y equals 6x plus 9. So was it 6x plus 9? Shoot, yeah. Okay. So this is our equation right here. Right here, we see our intercept right here, 0, comma 9. That's our y-intercept. So again, y-intercept is when x equals 0. So it will be right. So it will be right here. Now this value right here is called the x-intercept. Now the x-intercept is when y equals 0. So when y equals 0, x equals negative 1.5. But in this equation, in the y equals mx plus b format, b is always the y-intercept, and then that's easier to find, so we use that instead. So this is what the graph looks like. It has a large slope, which is 6, and intercept at 9. So let's compare this really quick with y equals x. So the blue line is y equals x, and the red line is y equals 6x plus 9. Now we can see that the intercept was shifted up 9 because of this plus 9 right here. So at the end, yeah, it's just shifted upwards. And we can see that the slope is much steeper than this one. You see how this one, the red line is yeah, much steeper than the blue one. That's because the slope of the red line is greater than the slope of a blue line. So that's just small things to know about. So like compare them with different equations. All right, let's keep going. We're gonna give you, say, 6 minutes to graph these. So you don't have to do everything, just try to rest 6 to 7 minutes. You can just hand draw them and quickly. All right, so we're just gonna stop right here. It's okay if you didn't finish. I'm gonna show you guys the graphs on Desmos. For some reason, my computer is not working. All right, there you go. So really quickly, y equals 3x plus 2. Equals 3x plus 2. Okay, so you can see that the 2 right here, this is the y-intercept. So your graph should look somewhat like this. Next one. Negative 2x plus 3. So this is negative slope. So it goes the other direction. Intercept is 3, but the slope goes the other direction because it's negative right here. All right, next one. Half x minus 1. So right now we have a fraction as a slope. Oops. It's for algebra 2. I cannot type. Half x minus 1. So when we compare this to y equals x, we see that y equals x is actually more steep than y equals half x minus 1. That's because the slope of y equals half x compared to y equals x is smaller. And if it's smaller, the graph will be not as steep. All right, so your graph should look something like this. Next one, negative 2x minus 2. Should look something like this. The intercept are here. And again, negative slope. And this time the y-intercept is negative, so it's down here. Last one, 4x minus 3. Look like that. The intercept is plus b. So if you have y 4x minus 3, it's actually plus negative 3. So then your intercept will be negative 3 instead of 3. All right, let's keep moving on. Now there's different forms of linear equations. So we learned slope-intercept form, which is y equals mx plus b. But then the other one is called point-slope form. Now again, m is the let me annotate. Okay, so annotate. Should give me a sec. Okay, again, m is the slope, and we again have 2 points. We have x comma 1 and x1 y1. Now the 1 right here just means it's a different point from the original x. For example, the points may be 1 comma 2, I don't know, for example 3 comma 2. Then again, remember slope is the difference or the ratio between y and x. So we're gonna find the difference between the y points. Actually, I'll make this 3. And then the difference between the x points. So what you can do is 3 minus 2 equals, since we're subtracting this and that, we have to subtract that and that too. It doesn't really matter what order you subtract it in, but remember to subtract it in the same order for both y and x. So what do we get? We get 1 equals m times 2. So now if we divide 2 from both sides, we get m equals half. So we can use the slope point-slope formula to get the slope easily. So in this equation, m is half. That's how you use that. All right, let's move on. Okay. All right, so I want you guys to do a little bit more writing right here. So we're gonna give you criteria such as the first example, and you're gonna write out the equation. So for the first one, given slope is 3, and the y-intercept is 0, negative 1. Write the equation in the form y equals mx plus b. Remember what m is and what b is. And for the point slope, for this one, I want you to write it into a point slope form. So given the slope is 2 and it passes through the point 2, 3, find the equation of the function. So I'll give you guys, I'll say 3 minutes to do that. right, so it's okay if you didn't finish yet. I'll go over the answers now. So, annotate, there it is. Okay, wait, draw. Okay, so remember that m is the slope and that b is the y-intercept. So then we plug it into the equation. We have y equals slope is 3, so 3x. Now be careful right here. It's plus b, but b is -1. So technically it's plus -1, right? Because b is -1, but we can further simplify that to y equals 3x minus 1. So that's the equation. So the answer to the first question is this right here. Y equals 3x minus 1. Now for the point slope method. So again, slope is m right here. And then we have a point 2, 3. Now we're just asking the equation of the function in this form. So remember, this right here can be x1. And this right here can be y1. So we just plug it into the equation. Y minus 3 equals m is 2, x minus 2. And that's it. That's the point slope formula, or point slope style. If you want to change it into slope intercept form, then you need to multiply everything out and then also isolate y on one side and do everything. But this will be the answer right here. All right, let's keep going. Next. Okay, so let's graph systems of equations now. Okay, so when you graph systems of equations, it's basically the same as graphing y equals mx plus b points, but then now there's 2 of them. And if the question is like 3x plus 2y equals 8, I'm not going to solve this one, but just as an example, if that's one of the equations, you have to put them into y equals mx plus b form or point slope form or a form where you can graph it. But basically, what we're going to do is graph both of the lines and then check out where they intersect. And that point is going to be the solution. And that's the beauty of graphing. So let's do an example. Y equals x plus 1. So we know that the y-intercept for this equation is 1. So we know that this right here is a point. And we also know that if we plug in x equals 1, we get 1 plus 1 equals 2. So we get 1, 2. So right now the points we have for this equation are 1, 2 and 0, 1. So 1, 2. So right here. Yeah, just approximate it. I'll put it on the Desmos after this. Now we have our first graph. And now for our second graph, I'm going to use a different color. Let's use red. So now we know that the y-intercept is -8. So know that there's going to be a point right here. Let's just estimate it. -8. This is going to be a point. Now, if we plug in 1 into the equation, it's we're going to have -2 minus 8, which is -10. So we're going to have 1, -10 is our other point. 1, -10. So it's all the way right here. 1, -10. Shoot. But yeah, the point is right here. Now we connect the line. This isn't really drawn to proportion, but where you see how the 2 points intersect right here, there's going to be a point for that. So there's going to be an x value and y value for that. And the x value for that will be the solution to this equation, and the y value will be the solution to this equation right here. So let's try out with Desmos. Clear. Okay. Okay, again, let's use these equations. So we're going to first graph the first one. Y equals x plus 1 right here. And we're going to graph the second one. Y equals 2x minus 8. Boom, right here. So you can see that the red line is y equals x plus 1. The other one is y equals negative 2x minus 8. Now we see this point right here as an intersection point. So that will be the solution. Now the intersection point for this equation is negative 3 comma negative 2. So the x value will be negative 3 and the y value will be negative 2. So this will be the solution to the equation. This is the beauty of graphing. Once you put two equations on the graph and find out where they intercept, that means that's the solution. So in a sense, yeah, graphing can always give you the right answer, but it may be more of a hassle to use than substitution and elimination. All right, now you try this one. I'll give you a minute or two to do it. It's okay if you don't finish. Y equals negative 3x plus 2, and y equals 2x minus 3. All right, okay. Now I'll show you, due to time, I'm going to show you the equation on Desmos. So the graph should look something like this. The intersection point should be 1, negative 1. So when you plug 1 back in, you should get negative 1 as y for both equations. So yeah, it intersects in the fourth quadrant. Remember, first quadrant, second quadrant, third quadrant, fourth quadrant. All right, let's keep going. Oh, okay, some extra information. If two lines never intersect, that means they are no solutions. And two lines will never intersect if they have the same slope. So for example, y equals 4x plus 3, y equals 4x plus, I can say a random number, 1, 2, 5, 9, 6, 8, 0, plus that gigantic number. Oh, I can't read my own handwriting, I'm sorry. But it doesn't matter because the slope of both equations is 4. So then there's not going to be any solutions because they're just going to be parallel to each other the entire time. They're going to look something like plus 3 is here, and then the other equation is going to be way off. It's going to be parallel, always the same distance from each other. It's never going to intersect. Now, if two lines are exactly the same, this goes without saying. For example, y equals 2x plus 3, and then again, y equals 2x plus 3. There's infinitely many solutions. So the line's going to look something like 2x plus 3. So something like that. And if the equation is the exact same, well, it's just on top of each other. So there's infinitely many solutions. All right, keep going on. All right, now we're going to do graphing inequalities. Now this one, when I was doing Algebra 1, I hated because it wasn't too hard, but it just took a lot of time and I didn't like it. And this happens on the SAT sometimes too, so this is really important. Similar to graphing a linear equation, when you graph an inequality, you're going to have to solve it first. So you're going to isolate y on one side, like a y equals mx plus b situation, and then graph the inequality. And then you're going to find the point to test the point is within the limits of the inequality. So I'll explain that in a bit. And when you're solving for a system of equations, it results in a single coordinate point. For example, 1, 1, 2, 16, a single point. But when you solve for inequalities, it's for a zone on a graph. Let's do an example to show my point. So we're going to do this example right here, y is greater than 2x minus 7, and then 3y is less than 6x minus 3. So let's first treat this as a y equals mx plus b equation. So we know that the intercept is -7, so it's going to be somewhere right here. Again, I'm going to use Desmos after this, so it'll be clear. But I'll tell you how what my mindset is when I do these types of questions. And we're going to try another point, 1. So when we plug 1 inside, we get 2 minus 7, which is -5. So know that 1, -5 is a point. 1, -5. Right here. So we know that this is a point and this is a point. Now we have 2 points, so we can connect it. Ignore that. All right, now let's do the second equation. Let's use a different color. Let's use green. So we have 3y is less than 6x minus 3. Now the first thing we can do is actually simplify this equation. So it becomes 2x minus 1. What you want to do when you see an equation like this is to see if you can simplify it first, because it'll be much easier. So let's again treat this as a y equals mx plus b equation. So we know that the intercept is at -1. So right here. And when we plug 1 in, we know 2 minus 1 equals 1. So we know that 1, 1 is another point. So around right here. Okay, this is going to be really hard to graph, but there's going to be an intersection point right here. And I should actually, for this question, I'm just going to use Desmos because I am very bad at drawing. But basically, you treat each equation as a y equals mx plus b point, and then graph it. And then you're going to test a point right now. I'll show you what I'm talking about. Let's do Desmos. We have this equation right here. This dotted line right here is y equals 2x minus 7. And this zone area right here is y is greater than 2x minus 7. Now, let's do a second equation. This is the equation right here. Actually, this is a bad question because I just realized the slopes are the same. But, all right, let's keep going. So you can see the part where red and black overlap. That's going to be the solution to the equation. Actually, let's change up the problem a little bit. Let's make it a different slope. So like right here. See how there's white stuff here and then black, red, and then there's a mix right here? The mix of the two colors will be your solution. The black part is y is greater than 2x minus 7, and the red part is, I changed the equation, y is less than 4x minus 3. Now, when you graph these, you're gonna find out a section of them is intersecting with each other. So then that's gonna be the answer. But how do we determine which side is the right solution? For example, this is the line y equals 2x minus 7, right? So then how do we know if it's gonna be strong? It's gonna be on here, or is it gonna be here? Which side am I gonna shade it in? Which side is the answer? So what we can do is test the point. Now, a common point to test is right here, the origin, 0, 0. So we have this equation right here. Y is greater than 2x minus 7. What we can do is plug in 0, 0 to the equation. So we have 0 is greater than 2 times 0 minus 7. And we know that 2 times 0 is 0. So this side is going to be 0 is greater than -7. Is that true? Yes, it is. -7 is smaller than 0. So we know that this side is going to be the solution. So we're going to shade this entire side in when we're graphing. So let's test the random point from the other side. Let's test 10 comma 10. Let's just make it big. So 10 is greater than, shoot, sorry, I'm losing myself. Okay, sorry, 20 minus 7. So it says 10 is greater than 13. Is that true? No, it's not. 10 is smaller than 13, right? So we know that this side is not going to be the solution. Now we're going to have to do that for both sides. So let's do the next equation. Let's test it. We can test the point 0, 0 again, because it's easy to test. So when we test it, we get 0 is greater than 4 times 0 minus 3. Remember, you test with the inequality, not this thing. So you get 0 is less than negative 3. Well, is that right? No, it's not, because negative 3 should be smaller than 0. So we know that this side is wrong. So once you know which side, test one point and it's incorrect, you basically know the other side is going to be the correct one. So this one's probably going to be the correct one. But just for practice purposes, we're going to check with another point. So let's use 2 comma 2 because it's right here. 2 is smaller than 4 times 2 minus 3. So that will become 2 is less than 8 minus 3, which is 5. And is that true? Yeah, it works. So we know that it's going to be shaded right here. Now when we combine those two, we're going to see this. So first one, we know that this side is the correct side, right? And boom, this side is the correct side. So, and then we're going to see an overlap right here. That overlap is the answer to this question right here. Graphing these questions. That answer is this right here, this section right here. Now, I'll tell you guys something really quickly. You see how it's a dotted line? That is when we use greater or less than. When we use greater than or equal, let me see if I can pull it up. Okay, you see how it's a solid line now, right now? So when it's greater than or equal to, or less than or equal to, we always use solid lines. Now, why do we do this? Solid lines indicates that the points on the lines are part of the solution because it's equal to. But if it's a dotted line, like this red line right here, it means the points on the line are not part of the solution because there's no equal to right here. So this is really important because your teacher will probably dock you points off of it if you don't do it correctly. If it's greater than or equal to or less than or equal to, it's going to be a solid line because the answer is inclusive, which means the answer belongs on the line. And if it's not, if it's just greater than or if it's just less than, it's going to be a dotted line right here. Wait, I think we're basically